All right, everyone. Today we're going to kind of be taking a look at our second part of our day one notes here. So Mr. Powell kind of introduced you guys to some of our concepts here on the first page. He really kind of dove into talking about positive, negative angles, angles that have rotations greater than 360. He reiterated that definition of what a radian is. Radians, a rotation of 1 radian occurs when the radius of r of the circle of revolution is equal to the length of the arc s subtended by that angle. So we really kind of hammered home that idea of a radian, which allows us today to really focus on being able to solve applications using proportions relating to angle measures and arc length in terms of the area. So angle measure, angle arc length, and areas in a circle, the angle theta of rotation, the length s of the arc that's subtended by that angle, and the area of the sector of the sector created area all are proportional to one another, meaning that their proportions, their ratios are equal. So I'm going to kind of just draw you a little picture here. So here we have our angle measured by some value of theta in radians. So that is our central angle. So our angle of rotation measured by in radians is theta. Here is our arc length, S. And then if we think about the area, that would be all of the space in between. So all of the space in between there would be A. So when we think about a proportion or a ratio, we're thinking about the part over the whole. We have just a little piece and we put that over the entire section that we are looking at. So if we think about our angle theta, that's a part of the whole being 2 pi radians. So if we measure theta in radians, 1 revolution around an entire circle is 2 pi radians. So theta represents part of that 2 pi. Now, if we think about S is our arc length. Our arc length is a portion of the circumference measured by 2 pi r. Our area of that shaded sector is part of pi r squared, representing the area. So if we really kind of think about these proportions being equal to one another, then we can find the arc length by multiplying the radius times our angle of rotation, theta. We can find the area from 1 over 2, or 1/2 times r squared theta. So where do these formulas come from? If you set these two equal to each other, for example, and we cross multiplied, and we solve for s, you would see that the 2 pi's would cancel, and you would be ending up with r times theta. We could set the second two proportions equal to each other, which we already know they are. They're proportional. Cross multiply, solve that equation for a, and we're able to derive these formulas from the proportions. So as you work through these examples here in the next couple problems, we can do this as part over a whole or use our formulas as well. So in our first example, it says find the angle and the area of the sector shown below. So I know that 3 centimeters is equal to S. That's going to be equal to our arc length. My radius is equal to 10 centimeters. So if we want to know what our angle of rotation is, 3 would be equal to 10 times theta. So theta would be equal to 3 over 10 radians. That's just from using this formula here. Now we could also set that up as theta over 2 pi is equal to our arc length of 3 over 2 pi times 10. And that would be if I use my proportions up above. I've substituted in my value of 3 for the arc length, 10 for the radius. We can go ahead and cross multiply here and solve this algebraically, and you would still end up with theta equals 3 over 10 radians. So if we wanted to find our area, that's 1/2 times the radius squared. We know our radius is 10, times our angle of rotation. Because our angle of rotation here, theta, sweeps out that shaded area. So that's why we're taking 1/2 times the radius squared times that angle of rotation, because we're not making a full revolution around the circle. We're not rotating that full 2 pi. So we're only looking at just a portion. So this would give us 10 squared is 100 over 2 is 50. 150 over 10. I think that sounds right. I'm doing it all in my head here. That sounds reasonable. 150 over 10 simplifies to an area of 15 centimeters squared. All right, in our next example here, we're going to find the radius of the circle and the length of the arc of the sectors shown whose area is 9 square inches. So we know that A is equal to 9 square inches, and then our measure for theta is equal to 0.5 radians. Now remember up above we talked about the part over the whole. And we set up all of these proportions. These different ratios are proportions because they're all equal to one another. So the angle of rotation, the length of the arc length subtended by that angle, our area, all of those proportions are equal. So in this case, if I only know the area and theta, I'm going to use theta over 2 pi is equal to the area over pi r squared. You can use any combination here of these ratios. They're all proportional to one another, meaning they are equal. So 0.5 is theta, 2 pi, my area was 9 over pi r squared. We're going to go ahead and try and find our arc length here first. Or sorry, our radius here first. We could try and find the arc length, but you would realize that if you're trying to find the arc length, well, you would also need the radius in order to do that. So that's not going to be very helpful for you right now. So we can go ahead here, cross multiply, however you guys want to think about this. But we would have 1/2 pi r squared is equal to 18 pi. So remember, we are solving for r here. So if I divide both sides by 1/2 pi, we would have r squared equals 36. So r would be equal to 6. So our radius becomes 6 inches. We also could have used this equation up above. 9 is equal to 1/2 the radius squared times 0.5. You're going to end up in the same place. So whether you're choosing to use the proportions or you are just choosing to use your formulas, in the end, you're still going to end up with the same final answer. Okay, the last thing here that we need to find was our arc length. And now we know that our arc length is equal to the radius times theta. Our radius was 6. Theta was 0.5. The arc length here would be 3 inches. So we have a radius of 6 inches and an arc length of 3 inches. I'm going to let you guys try the last example, and I will show you the answers. All right, in our last example here, we gave you a slice of pizza. It's 8 inches long. The crust is 6 inches long, so your radius was 8. Arc length was 6. Before we find the area, you would need to find what your measure for theta was. So I did that first. Theta was equal to 3 over 4. And then I was able to find the area of my pizza slice, because that's how much pizza we would need to cover the edge. Because you're only finding a sector, we needed to know what that measure in radians was. And it's approximately 24 inches squared for that area of pizza. So after you find the area of the entire pizza and divide it by the one slice that you started with, you would have approximately 8 slices. So when do you ever need to know how to use any of these proportions? Anytime you eat a pizza and you're trying to figure out how much you need for your friends. Let us know where you have any questions, and good luck on tonight's assignment.